Welcome to Code Physics channel, where we solve physics problems. In this video, we are going to solve some questions relating to different topics. Listen carefully and enjoy. The first question we have is define capacitance. Capacitance is defined as the ability of a capacitor to store charge. What are the factors that determine the capacitance of a capacitor? There are three factors that determine the capacitance of a capacitor. Number one, we have the area of the plates. Number two, we have distance between the plates. And number three, the dielectric material between the plates of the capacitor. The next question is telling us that three capacitors of capacitance 3 microfarads, 6 microfarads, and 12 microfarads are connected in series and then in parallel. Then the first question is telling us, with the aid of a diagram, determine the effective capacitance in series. And then the second question is telling us, with the aid of a diagram, determine the effective capacitance in parallel. So let us first of all look at when the capacitors are connected in series. When they are connected in series, they're going to be in a line, as we can see here. We start with the 3 microfarad capacitor. It's joined in line with the 6 microfarad capacitor. And then lastly, with the 12 microfarad capacitor. Now, when capacitors are connected in series, the formula we use is going to be 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3, where C1, C2, and C3 represent the different capacitors. In this case, there are 3. So C1 represents the first capacitor, C2 represents the second capacitor, and C3 represents the third capacitor. So 1 over C is going to be given by 1 over 3 plus 1 over 6 plus 1 over 12. And if we work it out, we are going to get an answer of C is equal to 1.71 microfarads. The second part was telling us to get the effective capacitance when they are connected in parallel. This is parallel connection. In parallel connection, they have the same voltage. Okay? And if I have a parallel connection, the formula changes. Instead of using 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3, now we are going to use C is equal to C1 plus C2 plus C3, from which I'll get C is equal to 3 microfarads plus 6 microfarads plus 12 microfarads, which gives us an answer of C as equal to 21 microfarads. We are told that a capacitor has a PD of 30 volts between its plates, and its capacitance is 1.5 microfarads. Find the charge stored. To find the charge stored on the plates of a capacitor, we use the relationship that is charge is equal to capacitance times the voltage. Okay? This is the formula that relates charge, capacitance, and voltage, or potential difference. So, we've said here, where Q is the charge, V is the voltage, and C is the capacitance. And therefore, we are going to come and say charge Q is going to be the same as 1.5 microfarads times 30 volts, which is going to give us charge is equal to 45 microcoulombs. Or we can write 45 times 10 to the power negative 6 coulombs. Question number 2a says state Ohm's law. Ohm's law states that the potential difference across the ends of a conductor is directly proportional to the current through the conductor, provided that other physical factors are kept constant. The next question was telling us to plot a graph of current against voltage for a metallic conductor. Now, a metallic conductor obeys Ohm's law, which means that current is actually proportional to the voltage. And if these two variables are proportional, then you're going to get a straight line, and this straight line is passing through the origin. So the graph is going to be a straight line that is passing through the origin. Now here on the y-axis, I put the current, and on the x-axis, I put the voltage. The next question is telling us to study the circuit that is given below and then answer the questions that follow. The first question is, what is the current in the circuit? The second question is, what is the PD across the 10 ohm resistor? And the third question is telling us, how do you compare the PD in the 10 ohm resistor and the 2 ohm resistor? Explain your answer. This is our circuit where we have 3 resistors that are connected in parallel, and they're connected to a source of 9 volts. Now to get the current that is passing through the circuit, you're first of all going to get the effective resistance of the circuit. And because they're connected in parallel, we are going to use the relationship 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is for a parallel connection for resistors. So the first resistor is having a resistance of 10 ohms, the second one is having a resistance of 2 ohms, and the third one is having a resistance of 1 ohm. If you work it out, you're going to get an effective resistance of 0.625 ohms. But current is given by the relationship voltage divided by resistance. And since we have the voltage of the circuit, which is 9 volts, and we have the resistance of the circuit, or the effective resistance, then you're going to come and say that current I is given by voltage divided by resistance, which is 9 divided by 0.625, and that gives me 14.4 amperes. The next question was telling us to find the PD across the 10 ohm resistor. The PD across the 10 ohm resistor is going to be 9 volts. Why? Because the resistors are connected in parallel. And when resistors are connected in parallel, they have the same PD as the source. That means that if our source is having a voltage of 9 volts, then all these individual resistors that are connected in parallel are also having a voltage or PD of 9 volts. This question is telling us to compare the PD of the 10 ohm resistor and the 2 ohm resistor. Now we've already done this in the previous question. We said that if resistors are connected in parallel, they have the same PD. Now these 3 resistors, that is 1 ohm, 2 ohm, and 10 ohm, they are all connected in parallel. Now because they're all connected in parallel, they're going to have the same PD as the PD of the source. That means that the voltage across the 10 ohm resistor is the same as the voltage across the 2 ohm resistor, and this is equal to 9 volts. The next question is telling us to define pressure. That is the first part. And the second part is telling us to give the factors that determine the pressure in liquids. And the third part is telling us, explain why it is easier to cut meat with a sharp knife than with a blunt one. And lastly, we are told a body of density 3000 kilograms per meter cubed has dimensions 0.5 meters by 0.6 meters by 0.02 meters. Now the first part is telling us what is the volume of the body. Number 2, what is the mass of the body. Number 3, what is the maximum pressure the body exerts on a leveled ground. And number 4, what is the minimum pressure it exerts on a leveled ground. Pressure is the force acting normally per unit area. What are the factors that determine pressure in liquids? These are, number 1, we have density of the liquid. And number 2, we have the depth of the liquid. Explain why it is easier to cut meat with a sharp knife than with a blunt knife. This is because a sharp knife has a very small surface area. If it has a very small surface area, it means that the pressure that is going to be produced is going to be very high, and therefore little force is going to be needed when you're cutting the meat. That is for a sharp knife. But if you have a blunt knife, you find that the surface area is going to be bigger relative to a sharp knife, and therefore that means that the pressure that is going to be produced is going to be little, or it is going to be low. So you have to use more force to make the knife cut. So the next part, our body looks almost like this, where we have the length as equal to 0.6 meters, the width is 0.5 meters, and the height is 0.02 meters. Now the first part was telling us to find the volume of the body, and volume of a body, of course, is given by length times width times height. So our volume is going to equal to 0.6 times 0.5 times 0.02. This gives us a volume of 0.06 meters cubed. Now, the mass of the body, if I have the density of the body, I have the volume of the body, it is easier for me. It is okay. It is possible for me to get the mass of the body, because I know that mass is given by density times volume. So if you have the density, you have the volume. That means that I'm going to multiply my density with the volume of the body, and therefore I'll be able to get the mass of the body. So if the density is 3,000 kilograms per meter cubed, and you've calculated the volume as 0.06 meters cubed, then if you multiply these two, we are going to get a mass of 180 kilograms. The next question was telling us to find the maximum pressure that this body exerts on the floor, which is leveled. Now I know that maximum pressure is going to be given by force divided by smallest area. In other words, if I'm going to get the biggest pressure, I get the force. In this case, it's going to be the weight of the body. I divide it by the smallest area of the body. Okay, because if you divide it by the smallest area, you're going to get a big pressure. But if I divide it by the biggest area, I'm going to get a small pressure. Therefore, I'm going to use the relationship that maximum pressure is equal to force divided by smallest area. Now, do I have the force? I don't have the force, but I have the mass of the body. And if I have the mass of the body, I can be able to get the weight of the body. And weight of a body is a force. Therefore, I'm going to come and say that force is equal to 1 mass times acceleration due to gravity, from which I'm going to get my force as equal to 1,800 newtons. Now, what do I do to get the smallest area? I look at my shape. I look at my body. Okay? And if you look at your body, you look at the sides. You look at the face, which is having the smallest dimensions. In this case, it's going to be 0.02, this one here, and it is going to be this one here, this length here, which is going to be 0.5. So if I have 0.5 and 0.02, that is going to give me the smallest area. But if I use the dimensions of 0.5 and 0.6, that is going to give me the biggest area. And yet for me right now, what I'm looking for is the smallest area. So we come and say smallest area is going to be given by 0.02 times 0.5. Okay, and then if I get the smallest area as 0.01 meters squared. Now we are supposed to get the maximum pressure. Okay, maximum pressure in this case is going to be given by our force divided by the smallest area, and in this case we are going to get maximum pressure as equal to 18,000 newton per meter squared. Maximum pressure is going to be given by force divided by the biggest area. Now the dimensions of the figure that give the biggest area are going to be 0.6 meters and 0.5 meters. When we multiply these two, we are going to get out an area, which is going to be the biggest area. Okay, so if I multiply them together, I'm going to get an area of 0.3 meters squared. Therefore, minimum pressure is equal to 1,800 newtons divided by 0.3 meters squared, from which we get our minimum pressure as equal to 6,000 newtons per meter squared. The next question was telling us to state Archimedes' principle. Now, Archimedes' principle states that if a body is totally or partially immersed in a fluid, it experiences an upthrust force which is equal to the weight of the fluid that is displaced. In the next question, they gave us a body of mass 60 grams and its volume was given as 100 centimeter cubed. And the question was, will this body float? Now, the first thing we have to do is to find the density of this body. Okay? After finding the density of the body, we are going to compare it with the density of water, because in this case they are telling us that will this body float in water? Will it float on water? Now, the condition for a body to float on a liquid, okay, is that the density of this body must be smaller than the density of this liquid. So if I find the density of this body, I'm going to compare it with the density of water. If the density of this body is bigger than the density of water, then this body is going to sink. But if its density is smaller than the density of water, then it is going to float. So my only target that I have to get right now is to find the density of this body. And since I have the mass of the body, I have the volume of the body, I'm going to use the relationship that density is equal to mass divided by volume. And if you happen to do this, we have that the body's mass is 60, the volume is 100, so density is going to be given by 60 divided by 100. And if we divide here, we are getting an answer of 0.6 grams per centimeter cubed. Now the density of water is 1 gram per centimeter cubed. And as we can see, 0.6 is much smaller than 1. And so because the density of the body, which is 0.6, is smaller than the density of water, which is equal to 1, this body here is going to float. The next question was telling us to find the apparent weight of the body in the liquid. Okay? They gave us the density of the liquid, and at the same time they gave us the density of the body. Now in this case, we have the real weight, or the weight of the body in air. Now I know that if I have the weight of the body in air, I can be able to get its mass, because I know that weight is equal to mass times acceleration due to gravity. So if I use this relationship, I'm going to get a mass of 8 kilograms. Okay? But now, this mass of 8 kilograms, we are going to change it to grams. And I know that 1 kilogram is equal to 1,000 grams. So that means that if I have 8 kilograms, that is going to be the same as 8 same as 1,000, which is going to give me 8,000 grams. If the density of the body is 1.6 grams per centimeter cubed, that means that I can be able to get the volume of this body. Now, why am I finding the volume of the body? It's because of one reason, and that is that the volume of the body, the whole volume of the body, is equal to the volume of the displaced fluid. Whenever you get a body and you insert it in a fluid, or you immerse it in a fluid, this body is going to displace an amount of fluid, in this case a liquid, that is equal to the volume of the body. So that implies that if the body is having a volume of 500 centimeter cubed, then the volume of the liquid that is going to be displaced is going to be 500 centimeter cubed. So if they give me the real weight, they give me the density of the body, the first thing that I'm supposed to do is to find the volume of the body. Yes, because when I know the volume of the body, I know the volume of the displaced liquid. And that's what we are going to do here. So we have a mass of 8 kilograms, and we are getting it, we change it to grams, it becomes 8,000 grams. Now the density of the body has been given as 1.6 grams per centimeter cubed. So this implies that the volume of the body is going to be 5,000 centimeters cubed. Now this 5,000 centimeters cubed is the same as the volume of the displaced liquid. That's why we come and say here that volume of displaced fluid is equal to volume of the body. And so volume of the displaced liquid in this case is going to equal to 5,000 centimeter cubed. Now when you have the volume and you have the density of the fluid or the liquid, in this case we have a liquid, then I can be able to get the mass of the displaced liquid, because I know that volume times density gives me mass. Therefore, if you have 0.8 as your density of the liquid, I'm going to multiply it by 5,000, which is going to be the volume of the liquid that is displaced. And this is going to give me an answer of 4,000. So this 4,000 is the mass of displaced liquid. 4,000 grams. Okay? But what are we looking for? We are looking for the apparent weight. We are looking for the weight of the body in the fluid. But there is a formula which we learned, and this formula says that upthrust is equal to real weight minus apparent weight, where apparent weight is the weight of the body in the fluid. Now, real weight, we have it, is the weight of the body in air. So what I'm looking for right now is the weight of the displaced fluid, and the weight of the displaced fluid is equal to upthrust according to Archimedes' principle. So I get my 4,000, which is going to be the mass of the displaced fluid. 4,000, I'm going to change it to kilograms, which means that I'm going to divide by 1,000, and then I'm going to multiply by the acceleration due to gravity, such that I get the weight of the displaced fluid. And if you work this out, you're going to get weight is equal to 40 newtons. But this 40 newtons, which is the weight of the displaced fluid, according to Archimedes' principle, is equal to the upthrust. So this implies that our upthrust is equal to 40 newtons. Therefore, if we use the relationship apparent weight is equal to real weight minus upthrust, apparent weight is going to be 80 newtons, which is going to be the weight of the body in air, or the real weight, minus 40 newtons, and 40 newtons is the upthrust. So the apparent weight is going to be equal to